In this question, we have a child who takes these two slides down them, so the same child, and they are the same height, the two slides. And so we have gravitational potential energy, which is mgh, and the same thing down here. For both cases. And the change in potential energy is going to be due to the change in height, which is the same in both cases. So what we know is the gravitational potential energy at A and at B are equal to each other, which means it could be this choice or it could be this choice, and it completely excludes these two. Now, we are not told it's frictionless. We are told that the coefficient of friction is the same for both of those. So ultimately, we're trying to figure out what's going on with the kinetic energy at the bottom. Now, what should occur is, in both cases, all the gravitational potential energy would be converted to kinetic in both cases. And so the potential energy is lost, and all of it, if all of it's converted, then they'll have the same kinetic energy. But we know there's friction. And so there's work that gets done against friction. And the work done against friction is that force of friction times the distance. Now, what we do know is that the distance for B is greater than A. The next question then is, what about the force of friction? The force of friction is mu Fn. Now, the mu's are the same in both cases. So it ultimately is going to come down to what's the difference between the force normal. And what we know is when we have 0 degrees, the force normal equals the weight. But as that angle increases until we get a vertical line, at that point in time, the force normal is 0. So as the angle gets steeper, the force normal becomes less. And if the force normal becomes less, the force of friction becomes less. So by that token, making the angle smaller causes the force of friction to increase. So the work done on friction on B is going to be greater, not only because it's a longer distance, but also because there's a greater force of friction due to the greater the greater normal force. So that means that the kinetic energy at A, so if we have 1/2 mv squared, A squared, and 1/2 mv squared, B squared, if we have this going on, what we know is that the kinetic energy will be less, which means the velocity will be less. The velocity will be less, making the kinetic energy be less, making the kinetic energy less because the masses are the same. So that's why choice C is the correct answer. At A, there is more kinetic energy than at B.